Hi guys, welcome to another iOS tutorial from Confidence Labs. In this tutorial, we will be learning the concept of dependency container. Apart from that, we will also be using property wrappers in this tutorial. I have a separate lecture on property wrapper. I would recommend you all to go through that lecture as well because property wrappers is a super useful concept. We will be implementing this dependency container as a framework so that we can reuse it wherever we want. If we talk about the concept of dependency container, the first question that should come to your mind is what is dependency? If you already know what is dependency, then it's good. But if you don't know, let me tell you, if you're already developing iOS applications, you are already using this concept. It's just that you don't know the standard names used among developers. Let me show you multiple examples of dependencies. So here, let's talk about the above example, the profile class. Inside profile class, we have an initializer which takes an argument of type account manager. So it's very clear here that if we want to create an instance of profile class, then we need to pass it an instance of type account manager. So account manager instance is a dependency for the profile class here. And let's talk about the example we have below, the view control class. So inside view control class, inside view did load function, we are getting the name property from this user profile object and setting it as a text property of our username label. So in case the view controller is loaded, its view did load will be invoked, and if the user profile is still nil, then our app will crash. So user profile here is kind of a dependency for our view controller, because if it will be nil, then our app might get crash. Let's see one more example of dependencies. Here we have again taken the same profile class, but here inside its initializer it takes two arguments. One is of type account manager, another is type of user profile. So there are such cases in our application as well, when a class when a class have multiple dependencies. So according to me, dependencies in code is somewhat similar to the dependencies in real life. Suppose as an iOS developer, someone has given me a task to integrate a web service into my application. Then in that case, I need a web service from the backend team. So to complete my task, I have a dependency. I need a web service from the backend team. Until I get this web service, I can't complete my task. So this web service from the backend team is the dependency for me in this case. So similarly, in if you want to create an instance of this profile class, we have to give it an instance of account manager and user profile. In this case, these two instances are dependencies for this profile class. So now I hope you do understand the concept of dependencies. From here, let's move to our next question. What is dependency container? Suppose for an instance, we have two objects, account manager and user profile. These are two most commonly used objects at different places of your applications. So what you are going to do in this case? Are you going to create new instances of account manager wherever it is required? No, you can't create multiple instances of account manager. Why? Because account manager represents a single user's account which is logged in. So you should only create a single instance of account manager, and it should be passed, the same object should be passed at multiple locations where it is required. Similarly, you can only create a single instance of user profile which represents the profile of user which is logged in. You can't have multiple instances of user profile. So we can solve this problem using a global dependency container. What we will do is we will register our dependencies to our dependency container by calling the register function, and after calling this register function, this dependency container will hold all of our dependencies, I mean which we register, and wherever or whenever these dependencies are required, we will simply invoke the dependency dot resolve function and we can simply get it. Now we don't need any initializer with dependencies because we have dependency container. We can simply fetch the dependency we require from the dependency container. Before resolving a dependency, we must be ensured that it is already registered to the dependency container. So our code already looks much better. We don't need any lengthy initializer with dependencies. We can simply get the dependencies using the resolve function of our dependency container from any location of our application. But we can even further reduce our code using property wrappers. So using property wrappers, we can introduce another level of abstraction by hiding the call to resolve function of our dependency container. So you can see the difference. By using dependency container, our code looks much readable, much short, much maintainable. So let's start implementing this dependency container as a framework. Let's create a framework. Let's name it dependency container. Let's click next. Let's create it in documents. Let's create a new file, Swift file, and let's name it dependency container. Let's create a class called dependency container. We'll make this class public so that it can be accessed from the outside of this module. Public class. We'll create two functions. One is to register any dependency, and other one is to resolving a dependency. So what will be the type of dependency? Type of dependency could be anything, in the example I showed you, account manager, user profile, or any type. So it must be generic. Dependency. So this dependency argument represents the dependency that has to be registered, and this resolve function would also be generic. Okay, so these are the function to register and resolving a dependency. Now we will create a hash map dictionary which will hold all our dependencies. So we'll make it of type string and any object for now, but I'll change this later on in this tutorial. So now whenever the register function would be invoked, we will add the dependency in our dependencies dictionary. So let's do that, and we will use the name of the type of dependency as the key for our dictionary. So let's fetch the key first. Let's take a constant. We'll use the function type of, and we will try to get the type of this generic parameter dependency. And now we'll add this dependency in our dependencies dictionary corresponding to the key which represents the name of the type of dependency. And I'll also typecast it for now. I'll change this later on this tutorial. So we have implemented the register function. Now we will implement the resolve function. In resolve function, we will return back the ask dependency to the caller of this function. So again, we will try to get the key from the generic parameter, and we'll again create a constant dependency equals to dependency object for key. So this dependency would be optional. So what we will do here is we'll put a precondition. So dependency should not equal to nil. If dependency is nil, the app will be crashed with the message that we will provide here as second argument. So if dependency is nil, it means the dependency is not registered with our dependency container. So what we'll do is no dependency found for this type. Then we will also tell user that application must register a dependency before resolving it. Yeah, so now we will return the dependency, return dependency as not t. So again I have typecasted the dependency here, but I'll update all such codes later on. So all these functions and this dependencies property will be private. I don't want the user of this library to access them, so I'll make it private. Instead I'll create some static public functions which will be used by the user of this library. Let's copy this. Okay, so here I can't access a non-static property inside a static function. So for that we will create an instance static var shared dependency container dot init. Let's skip the static. No, I guess we need to have this static. Let me put it back. Yeah, now I'll invoke the register function, this non-static register function with the dependency provided by the user. Similarly, I'll create another public static function to resolve a dependency. And inside that I'll call the resolve function. So this implementation seems good, but that's not the case. We have a bug here, and the bug is all the dictionaries in iOS by default hold the elements inside it strongly. But that shouldn't happen. Why? Because whenever a user registers a dependency, the dependency container will hold it strongly. And even if that dependency is not needed anymore, it will still won't be deallocated by the operating system. Why? Because dependency container is holding that dependency strongly. So we need to break this thing. How we can do this? I have a quick solution for this. I have used the same solution in my previous tutorial, the generic multi-delegate pattern. So what we can do here is either we can replace this dictionary with ns map table, but instead of that I will use a quick solution. So what I'll do is I'll create a new file. Ns map table actually hold its element weakly, so I'll create a new, but we are not going to use that ns map table here. I'll create a new class So in this class, I'll paste my implementation of weak class I created in my previous tutorial, generic multi-delegate pattern, but I'll explain it here as well. So we have a class called weak. It conforms to equitable protocol. What does that mean? It means that two instances of this weak type can be compared using double equals to operator, and inside this function we are comparing those two instances on the basis of the value property that we have here. If value property will be equal, then yeah, those two instances of weak type would be equal. And yeah, as we have a value property inside this weak class, but it is a weak property, so whatever we put inside this value will be held weakly. So we also have an initializer, and in this initializer we pass a value of type any object, and that object will be held weakly by our value property of this class. So now instead of putting the dependencies directly into the dictionary, we'll put it inside our value property of this weak type. So that value property will hold those dependencies weakly, and those dependencies can be deallocated by the system anytime based on the application logic. Our dependency container won't hold those dependencies strongly. So the problem solved. Let's implement it. Let's replace this any object with weak, and now we will be facing too many errors. So let's go here. Let's create a constant of type weak dot init. Let's put the dependency inside it as any object, and let's put the weak object inside it. So the dependency would already be stored inside the value property of this weak type. And now let's fetch the dependency. So first of all, I'll replace the name here. I'll make it weak because now dictionary is holding the weak type of values, and I'll also change the name here in our precondition. So now I'll check if the value is inside the weak type of instance, the value is still there or not, because now the dependency is being held weakly. So dependency can be deallocated anytime by the system based on the application logic. So before resolving it or giving it back to the user who invoked this function, we must check it if it still exists or not. Okay, so let's call it dependency, and weak would definitely won't be nil now, because if it would be nil, then our app will crash here on the precondition. So I can use this forced unwrapping here because I know it won't be nil here. And this any object, oh sorry, this value could be nil here, so that's what we are checking here, and it should be of type T. Now we'll implement another precondition here, so I'll copy it here. So if the dependency is nil, it means dependency is already deallocated by the system. And now we don't need this, we can simply return the dependency. Oh, I just need to forcefully unwrap it because I know it won't be nil here, as if it would be nil, then the precondition would crash the application. And we are good to go, everything seems awesome. I'll just make this one private so it can be accessed outside from this module, or even outside of this class. Everything seems good, but now we will use property wrapper to introduce another level of abstraction. Let's create a new file. Let's name it dependency here. I have a dedicated lecture on property wrapper as well, but I'll explain a bit here as well. So to make a class a property wrapper, we need to use this keyword property wrapper with at the rate as a prefix, and every property wrapper must have a property of type wrapped value, and our property wrapper would be generic. So I'll use generic type here T, and the wrapped value would be of same type, and I'll have an initializer here wrapped extra p wrapped value of type T, and here self dot wrapped value is equal to wrapped value. So this is kind of a default implementation of a property wrapper. Now I'll show you how we can create an object of the property wrapper. Let's take a random class abc, and inside that we will create an object of property wrapper type. So first we will use at the rate, then the name of the property wrapper, and rest of the object we will create normally. So I have created an object of type this property wrapper, and I name it x, and I gave it an integer value. So this is a generic property wrapper, so this generic type would be replaced by int in this case. And the most important concept is whenever we give this uh, default value to a property wrapper, then its initializer will be called with that default value, and this one would be passed here as wrapped value, and that one will be assigned to this wrapped value property. So that's how the property wrapper works usually, but here we will do some changes. So let's not remove that, we'll update it later. So instead of asking for the wrapped value inside the initializer that will be called when default value is assigned, we will give it the initial value from dependency container by invoking the resolve function. So what will happen is, now let's make another class. Let's create a class called account manager. Okay, and here we will create an property which will represent this account manager. Let's try to understand the flow step by step. So first of all, we created a property wrapper of type account manager. So the first thing that will happen is this generic parameter would be replaced by the type account manager, and now the wrapped value is of type account manager. Then this property wrapper is created without any default value, so its initializer will be invoked without any default value or wrapped value. When the initializer is invoked, this piece of code will be executed. So dependency containers resolve function will be invoked, and the resolve function knows that this wrapped value expects a value of type account manager. So resolve is also a generic function. Now resolve will automatically infer the generic type as account manager. Let's move to this resolve function. This is a static function. Now it's invoking this private function resolve, this one, and inside that it will create a key from that generic type which is account manager. So it will create a string representation of account manager here, and then it will fetch the corresponding dependency to that key from registered dependencies, and then it will typecast it to type T, which is in our case is account manager, and return it back to the caller, which in our case is the wrapped value. So now the wrapped value contains an object of type account manager, which is actually a dependency which was registered previously. So one more interesting thing and the most important thing, whenever this account manager is accessed, it is actually backed by this wrapped value. It means whenever we access it, we will get the value of wrapped value, this property wrapped value. So if I will access it anywhere in my application, I'm actually getting the value of this wrapped value, which is in our case is a dependency of type account manager, which is fetched from this dependency container. So how beautifully our work is done in one line of code using property wrappers. One thing we should always remember is first we have to register a dependency. Only then we should try to resolve a dependency from any location of your application. Otherwise, our app will crash here at this precondition. So first register a dependency, only then try to access a dependency from any location of your application. So we are almost done here. Let's try to integrate this framework to a real life application and see how this framework will help us in a real world application. So I have already integrated this dependency container framework in one of my application. So I just drag and drop this Xcode project file into this application, and I have also added this dependency container framework in this embedded content section, and I'm good to go. Wherever I need to use any public class of this dependency container, I just need to import this framework by writing this. Let me show you. By writing this line, import dependency container. I just made one little change in the dependency container framework. I just make this property wrapper and its initializer and wrapped value as public property, so that it can be accessed from outside of the dependency container module. Let's go back to the app delegate. Yeah, so now I'll show you how I've used this dependency container in my application. So here these are few dependencies that I use need to access at multiple location of my application. So card file manager, so this app basically manages cards. uh, so card file manager is to manage the card file, to save and retrieve the cards from a file. Card manager has operations to add or remove or edit a card. And this is date manager, this is used to manage dates, so let's ignore this one. So when I created these objects in my did finish launching with option, I mean, you don't necessarily need to create all your dependencies here. It depends on your application logic. I just created it here because it suited me. So I created my dependencies here, and I just registered all those dependencies in my dependency container using the register function. So now I don't need to pass these dependencies anywhere from class to class and all blah blah. I just registered it with my dependency container. Now wherever I need it, I just get it using the property wrapper that we have created inside dependency container. Let's search this property container. So property wrapper, sorry. So wherever I need this card manager, I just use to create this property wrapper, and this property wrapper will internally get this dependency of type card manager from the dependency container, as I shown you before. So you can see I just need to create this object of type property wrapper when wherever I want to access this card manager. So the managing dependencies has become pretty simple by using this dependency container framework. So that's all regarding dependency container in this tutorial. I hope you guys learned a lot in this tutorial, and I'll recommend you guys to go through my other tutorials as well on property wrappers and generic multi-delegate pattern. My next tutorial hopefully would be on event bus or unit testing. And before leaving this tutorial, I'll tell you a little improvement that we can do. The problem here is this wrapped value is will hold the dependencies strongly. So to tackle that, what we can do is we can create a protocol that every dependency has to implement to register itself as a dependency. And here we can say, and now we can make this as unowned. So now in this case, uh, this wrapped value or this property wrapper won't hold any dependencies strongly. So this is good for our application logic. And but the thing is, every dependency like card manager, file manager has to confirm this protocol is dependency. So that's all in this tutorial. See you in the next tutorial. Bye bye.